Hello ladies and gentlemen, welcome back. This is Ms. Dubois giving a video tutorial for the last set of topics, or last goal rather, in goal 5. You can see by the topics that are highlighted, I almost made it to the end and then I ran out of space, and so we're going to be splitting this into 2 different videos. Alright, before I actually start showing the topics themselves, I want to talk quickly about what this is all about. This is about something called the coordinate plane. I'm going to be a math nerd for a second. The coordinate plane was first discussed / invented / discovered by a French philosopher named René Descartes, which is sometimes referred to as a result, the Cartesian plane. What we do is we're going to have 2 number lines, one intersecting, one on top of the other. So the first number line, you have 0, 1, 2, 3, yada, yada, yada. -1, -2, -3, yada, yada, yada. Over here we have 1, 2, 3, yada, yada, yada. -1, -2, -3, yada, yada, yada. And the thing René Descartes discovered as he was going through this is that some actually really cool kind of math starts to happen when you have these 2 number lines intersecting. And a lot of mathematicians are low-key kind of big nerds over this. You'll see coordinate math, Cartesian math pop up all over the place. The thing for you as a beginner to know is the coordinates, because of course, have names. So you have the x-axis on one side and the y-axis on the other. The way I have seen it discussed from middle school teachers is that it's y to the sky. That's how they try to label it. So the y to the sky, with that kind of neat little rhyme, reminds you that the y-axis is on top and the x-axis is pretty flat and chill, and that's why it's going to go horizontally. Now that's just what visually it looks like, and now we get to see some of the stuff that it does. So now we get to scroll down. Reading a point in quadrant 1, and we'll talk about quadrants in a later topic. Just want to get used to how this works first. You see how it says write an ordered pair for the location of the post office? Well, the post office is easy enough to find. We wander our way around aimlessly until we find post office. Huzzah! The thing is, when you're labeling it, the problem is that there's 2 number lines here. You have the x-axis over here and you have the y-axis over here, y to the sky. So what mathematicians decided is said, hey, you know what? We're going to keep this nice and easy for folks. What we're going to do is we'll slap on some parentheses so at least we know that it's sensitive, that it's important, it's a coordinate plane, it's going to be doing stuff later on. And then, because we are lazy and labeled it as x and y, we're going to name it lazily and use their x and y. In other words, the x part comes first because the x comes first in the alphabet. That's how René Descartes decided to do this. And then the y, letter y, since that comes second in the alphabet, that goes second in the listing. So when I'm looking at this post office, let me erase all of my beautiful little arrow work over here. There. So when I look, first I'm going to look down to the x-axis because the x number comes first. What does it meet at? It meets at number 2. Next, I'm going to look over. So this is done first, like a YouTube comment, first. And now I look over to the right to see what the y-axis is because the y is going to the sky, and that is going to be the second half of my coordinate. Ta-da! Like, honestly, it's kind of low-key pretty simple. Now we look over here. We're still looking for that darn post office, but now we're in a different city, so we're going to go wandering around. La 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 la. Where's my post office? Oh, there it is. Ta-da! So then we're looking at this coordinate, and now you notice it looks a little bit different. Well, actually, but not actually. You see, visually, it looks weird because it's on the axis, and specifically it's on the y-axis, and some people get a little bit hinky when they see that. But if you trace down, all the way down to find our x-coordinate, what number was this again? Let's scroll up and look. Oh yeah, this was 0. So our x-coordinate here is at 0. And now I look at the y-coordinate. Well, I don't even need to look anywhere. There it is, right there. It's going to be a 5. Let's find a different number. Let's see here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's pretend I know what I'm doing. This one. If I trace my way down, it's a 3. And if I trace my way over, it's a 5. That's what we're doing for our naming. Now that we know how to find a point, let's figure out how to place a point. And placing, because Rene Descartes loves making fancy words, he calls it plotting a point. So we're going to make our little baby graph. For now, we're not using the entire coordinate grid because this is training mode, and we don't want to overwhelm everybody. What's my biggest number here? 6. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1. It occurs to me, now that I'm doing this out, that I probably should have had these graphs pre-printed and ready. Oh well. So, now we know alphabetical order. X goes first, Y goes second. Y to the sky, X horizontal. Y to the sky, X horizontal. Y to the sky, X horizontal. Since we know what our X's and our Y's are, we can figure out we're going over 2. So it's going to, oops, that looked terrible. Let's try it again. So there's 2 on the number line. We're going to trace our way up. And then 5. 1, 2, 3, 4, 5. Trace our way over. Oh, look, there's my point. And that's all they're expecting you to do. Over here, what's the point? 2, 5. I got a wrong screen grab. All right, so we're going to erase that and make up our own point. What would be a good point? Let's do, how about 3, 1. That sounds good. There's my X, comma, there's my Y. So I'm going to go over 1, 2, 3. It's going to look somewhere here. I go up 1, look somewhere here, and there's my coordinate, and that's where I was going to be plotting my point. Over here, 6, 1. So 6 is the x-axis, 1, 2, 3, 4, 5, 6, and then I go up 1. And now you can see I'm good enough at this now that I don't even need to draw my tracing lines. So that's the very basics on how you read a point and how you plot a point. Let's get a little bit more complicated, because if you've noticed, it's only quadrant 1, which I know you don't know what that means yet. Hold that thought. I hear the question. Just give me a minute. So now let's look at all 4 pieces of the coordinate graph. And you can see it's a little hard to read because the letters are very small, but there's your label for X, there's your label for Y, there's your label for X, there's your label for Y. So they never not label it for you in case you get a little lost. And so now what's the city we're looking for? Seattle. Where is Seattle actually? I haven't actually looked at this yet. There it is. So if I'm looking for a coordinate for this, I know I need my X, comma, and my Y. Trace my way down to the X. The number is -9. Trace my way over to the Y. My number is 9. And there's my coordinate. What city are we looking for over here? Madrid. Okay. Let's see. Where is Madrid? Oh, it's all the way down here. I almost missed it. All right. And so I need an X and a Y. X comes first. X is the horizontal. So there's Madrid. Fight our way up. It's a -8. And then trace our way over, and it is a -8. That's how you're going through and you're labeling your points. And again, up here, we showed you how to do it with a graph. Now you want to make it. Down here, we showed you how to do it on a graph, and now we're going to make it. We're gonna make it if we try. There's my x-axis, there's my y. Now again, because it's in alphabetical order, I know I'm going to go backwards 3. 1, 2, 3. There's my -3. And for -5, I need my negative numbers. That's below. So I'm going to go 1, 2, 3, 4, 5. Trace my way over, and there's my coordinate. Not so bad. Now we do it again. X and y. We want 0, so we're not moving at all. And then we're going up. 1, 2, 3, 4, 5, 6. When you have a point like this, I don't know if you'll see it in a later topic, but this is considered on the axis, and we'll talk about that more. I believe it's covered in a later topic. Here we go backwards 1 because that's what the negative does. You're on the wrong side of the 0, and then you go up 1, 2, 3, 4, 5, 6. Theoretically, it's done evenly, and I don't think I did mine evenly, but you get the point. And see, there is the point. Ha 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 ha. Math puns. Yeah, that's cringe. Anyway, now we talk about naming quadrants. So I'm going to use these graphs up here because they're a little bit empty. So what's going to happen is you'll notice that there's 1, 2, 3, 4 different sections that the grid has been split into. Each of those sections actually has a name. So if you've noticed up here, it had said in quadrant 1. Well, that's the part that we're actually going to be doing down here, because this section up here where you had that little L shape for your axes, this is going to be quadrant 1. Quadrant 1. Then, because the world wants you to be confused, but we're not going to let it, it tends to go counterclockwise. So if you're looking for quadrant 2, it's going to be all the way over here on the left. Quadrant 3 is going to be below that, quadrant 3, and then quadrant 4 is going to be underneath the 1. So the trick to remember, the part that will make you confused otherwise, is that you're going counterclockwise. Counter means the reverse of the direction of a clock. All right? Now that we understand how that works, let's look over here. And since you have this as a quick little cheat sheet, if it was me, I'm just going to label it right now. So let's see here. Quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. That's the other thing René Descartes was great for, is that he loved Roman numerals for some reason. Quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. There's all nice and pretty. So now name the quadrant or axis that each point lies. And now we can do some labeling. This one is pretty obviously in quadrant 1, point N. If we look at point L, it's also now pretty labeled. This is quadrant 2. How did I get quadrant 1? There we go. Let's see here. This one over here is in quadrant, which one is labeled? 4. This one's the hard one, but it's not actually that hard because the label is low-key right there, right in front of us. This one is on the y-axis. Okay, now we're looking over here. That's quadrant 1. Over here, that's quadrant 2. Not so hard. This is quadrant 3. The fact that I already have these pre-labeled actually kind of makes this low-key easy. This one right here, a little bit hard until you realize it actually tells you what axis it's on. It is on the y-axis. And then over here, let's see here. Actually, you know what? I'm going to handicap myself. I'm going to take these off. There we go. Now, this one I know is quadrant 1 because we've done a lot of quadrant 1 things. Let's see here. This one, it's counterclockwise 1, 2, 3, 4. So this is quadrant 4. And then because I was just doing that 1, 2, 3, this one here is at quadrant 3. And then the letter P up here, it's not on a quadrant, it's on an axis, and there's the axis it's on. This is on the y-axis. And that's how you're going to go about labeling your quadrants and knowing which is where. Then after that, now that we have it, again, they get you trained to do it on the graph, and now we actually have to do it given its coordinates. What I like to do, because I will get my quadrants a little bit backwards when I'm labeling, is I will actually just draw a quick little coordinate plane right in the mouse. So 1, 2, 3, and 4. So now I know which is which. And what happens now is I can visually, you might not be at the point yet, but you will be definitely by the end of Algebra 1 and definitely by the end of Algebra 2. When I see that -7, -3, I know, okay, I'm going backwards 3 and down 2, so it's going to be in there, which means this is going to be quadrant 3. 8, 0, that's on an axis. The question is which one? That's my x number, so I'm going over 8 spaces, but then I don't move up or down. Therefore, this is going to be the x-axis. 3, 4, those are both positive numbers. I'm going over 3 and up 4, so therefore this is going to be quadrant 1. 5, -6, 5, -6, this is going to be quadrant 4. And doing this little doodle has made life easier for me as I go about this. Let's see here, 6, 2, over 6, up 2, that's going to be quadrant 1. Over 4, down 1, so that's going to be quadrant 4. 0, 6, that's an axis, and which one is it? That's going to be the y-axis. And you can tell because the y is the one with the number. Over here, the x-axis, the x is the one with the number, and that's a nice little shortcut when you don't immediately know how to figure out what axis it's on. Then -3, -4, so I'm going backwards and then down, so this is going to be in quadrant 3. 0, negative 1, I have a 0, but the important thing is that I have a y, so this is the y-axis. 3, negative 4, so I'm going over 3 and down 4, so that's going to be in quadrant 4. Negative 7 and then up 3, that's going to be quadrant 2. And then over 4 and then down 6, this is going to be quadrant 3. And if you don't have coordinate paper with you, if that wasn't in one of the supplies that you got over the summer, that's okay. I have plenty of coordinate paper in my classroom. Now, we're going to take it even a step further, because one of the things that I didn't point out, because I knew this topic was coming up, is that we have a lot of signs to take care of. So if you'll notice, where's my original axis? It's a little too high up. All right, I'll draw it from scratch. So we have our axis, we have our x, and we have our y. Anything in quadrant 1, it has a positive x and a positive y because I'm going over and up. That's the point. In quadrant 2, my x is going backwards, so that's negative, but I'm still going up on the y-axis, so that's positive. In quadrant 3, I'm going backwards. Yes, we already knew that, but we're going backwards also on the y-axis, which means both of these are negative. And then over here in quadrant 4, we have our x. We're going to the right, which means it's positive, and I somehow turned it on its side. But I'm going down for my y, which is negative. And there's another way you can do a little cheat sheet to get yourself all caught up. So what do we have here? X coordinate is positive. Y coordinate is 0. 0 is one of our key things. We were doing that all the way up here. If the y coordinate is 0, but the x has a number, it's going to be on the x-axis. And specifically, it's on the positive side of the x-axis, but I don't think that's in the drop-down. Now we have the x coordinate is negative. The y coordinate is positive. So which one is that one? X is negative. Y is positive. That's that one. Ergo, this is going to be quadrant 2. Quadrant 2. Let's see here. The x coordinate is positive. The y coordinate is negative. That's down in here because there's my x and there's my y. Ergo, this is going to be quadrant 4. 4 Roman numerals. And then the x coordinate is negative, but the y coordinate is positive, so that's going to be quadrant 2. Quadrant 2. That's how the quadrant system works. You don't really, in some of the higher level math, you don't really use the quadrants, but knowing how they exist will be helpful, especially in some of the back end of Algebra 2 when you get there. So it's good to have it at least somewhere stored in the back of your head. Next, distance is going to be a huge thing in Algebra 1 and especially in Algebra 2, so it's a good thing that you're learning this in pre-algebra. The big thing for this for now, because you'll notice they share a common coordinate, is you don't have to do any fancy formula stuff. It's just a counting game. So if I'm looking at the space between H and G and I need to find the distance, how many boxes am I traveling? 1 box, 2 box, 3 box, 4. There's a Dr. Seuss rhyme in there. So the distance here, the distance equals 4. Next, find the distance between I and J. So I'm counting boxes. 1 box, 2 box, 3 box, 4, 5 box, 6 box, 7 box, more? Anyway, so this was, I've already forgotten. Oh my gosh. 1, 2, 3, 4, 5. So this is distance of 5 boxes. Distance equals 5. And for my mental math people, what I would do is I'm looking at the -7 and the -2. 7 minus 2 is 5. Over here, I'm looking at 2 and I'm looking at 6. 6 minus 2 is 4. And when you see Ms. Dubois doing her mental math really fast, that's how I'm calculating my distance. Now we have, again, since you have that little cheat sheet that I just gave you, now we have a shared coordinate given not the graph, but rather their coordinates. Because again, we're going to train you on the coordinate plane and then we're going to show you how to math it. So if you'll notice, we have, make my pen bigger, we have the -7 here and the -7 here. I don't physically need them because that's the shared point. Over here, I have a -6 and a -6. Since that's the shared point, that's not the one I want. So what I'm looking for instead is to find the distance between 6 and 3. And since I already told you the trick, this is subtraction. We'll do 6 minus 3, and the distance is 3, which is our final answer. Over here we have 7 and 3, so 7 minus 3 is going to get us our answer, which is 4. Let's do a third example just in case they try to screw with you. We'll do -3 comma -8, and then we'll have -5 and -8. So again, you have that -8 in common, so we can erase it because we don't really need it. We can, however, do the subtraction. So what is -3 minus -5? Double negative is a positive. Brain broke. I did it backwards. Gosh darn it. I always go from left to right, and I'm supposed to be going from... Okay, what is... Yeah, so it's going to be a distance. Okay. I caught my own mistake. My brain just turned off for a second, and I acted... Oh my God, I'm an idiot. I'm embarrassed. Okay, we're
not an idiot.
We're not going to talk about the mistake that I just made in my head. Here's the trick. I move 3 spaces over on one side, and I move 5 spaces over on the other. 3 plus 5 is going to get me 8. So it's not subtraction, that's the thing. So let me clarify a little bit better so that we don't have a mistake later on when you're doing the topic. So when you're on the same side of the number line, so if you'll notice, these two numbers are both on the positive sign of the axis. These two numbers are on the positive sign of the axis. These two numbers, that's what my brain was doing, are on opposite sides of the axis. You are going to be subtracting. If you are on opposite sides of the axis, like this one right here that made my brain go absolutely nuts, what you're doing is you're going to be adding. So what is 3 plus 5? And that's what gave me the 8. My brain really did not process that, and it must be because I've been working on making videos for... This is my 9th hour, so we're doing well. All right, filling in the tables using this function rule. So this is what we're trying to do here. This is actually low-key pretty straightforward. What we're doing is just filling in a number. So you see how we have an x here? We're going to plug it in to the x here. So what is 23 minus 2 times 1? That's order of operations. So 23 minus 2, which is in fact 21, which is our answer. Now for my mental math people or for my calculator people, this is going to go by really super fast. If you're not one of those people and you have to write it out, by all means do so. But because I have to do, kind of a lot of these, I'm going to mental math these for a little bit. So 3 times 2 is 6. 23 minus 6 is 17. 4 times 2 is 8. 23 minus 8 is 15. 5 times 2 is 10. 23 minus 10 is 13. That's how you're going to be going through the math. And again, you can do it out the long way like we did for our first problem. And I'll do this next one out the long way too. 20 minus 4 times 1. Order of operation. How did I write 10? What the heck, Ms. Dubois? 4 times 1. 4 times 1 is going to be 4. And then what's 20 minus 4? 16. And now Ms. Dubois shows off and does it in her head. 2 times 4 is 8. 20 minus 8 is 12. 3 times 4 is 12. 20 minus 12 is 8. 4 times 5 is 20. 20 minus 20 is 0. And now again, 3 plus 4, that's a terribly written 4, times 5. So 4 times 5 is 20. 20 plus 3 is 23. So that's my first box, and now I mental math it through the rest. 7 times 4 is 28. 28 plus 3 is 31. 9 times 4 is 36. 36 plus 3 is 39. 10 times 4 is 40. 40 plus 3 is 43. Ta-da! And now, even though when I was going through my screen grabs, that's a two-step. This is a table. They're two completely different things. But if you look at the table, it's still exactly the same thing. Figure that one out for me, okay? So we're going to do this again. -4 times -1 plus 3. Double negative is a positive. 4 times 1 is 4 plus 3, which is 7. And now I'm going to mental math the rest of it. 4 times 0 is 0. 0 plus 3 is 3. -4 times 1 is -4. -4 plus 3 is -1. 2 times -4 is -8. -8 plus 3 is -5. Now we do it again. 5 times -2 minus 3. 5 times negative 2 is negative 10 minus 3. Negative 10 minus 3, same sign, so you add, that's negative 13. There's my first number. And now we speed run it with our mental math. 0 times 5 is 0, 0 minus 3 is negative 3, 2 times 5 is 10, 10 minus 3 is 7, 4 times 5 is 20, 20 minus 3 is 17. Not so bad. Now we do it again. 5 times negative 1 minus 1. Multiplication first. So 5 times negative 1 is negative 5 minus 1. Negative 5 minus 1 is the same sign. Same sign means we add, which is negative 6, and that's our first number. And now we speed run it. 5 times 0 is 0. 0 minus 1 is negative 1. 1 times 5 is 5. 5 minus 1 is 4. 2 times 5 is 10. 10 minus 1 is 9. And that's as far as I was able to get. I almost made it. We're in the middle of family 3. We have a little bit more to talk about with the lines, and then after that we'll be talking about intercepts, which is just a specific part of a line. And then finally we'll be done with goal 5, and we'll be done with pre-algebra. Huzzah! All right, ladies and gentlemen, thank you kindly for all of your paying attention. I look forward to seeing those topics done. As always, stay happy, stay healthy, stay safe, and transmission.